This lecture is regarding chapter 2. Okay. It's entitled the following: Economic Model Trade-off and Trade. Okay. All right. So before we start, I just want to say and give you an introduction of economics. Economics is a science. It's a social science because we study people. Okay. And economists are scientists because we apply something called the scientific method. All right. Scientific method is you devise a theory, you collect data to test this theory, you analyze the data, and you verify or you say the theory is wrong. And then when you say the theory is wrong, you got to revise the theory, and then you rinse and repeat. Now, in real life, and by the way, this is what I'm talking about here is applying the scientific method. That is basically what academic economists do. There's many different types of economists, and this is generally, I'm focused on academic economists, those who are professors at large universities, the large research universities, the UCLAs, the Berkeleys, Harvard, Ohio States of the world. Okay. Now, in these, large universities, the top 1%, they're the ones who devise the theories. They're the superstars. They're the LeBron James of economists. They're the ones that walk around, and they're the ones who create theories. The rest of the schmucks, kind of like me and everybody else, we're the ones who collect the data and analyze the data, and hopefully we re-verify what these superstars say. If you refute what these superstars say and you're saying they're wrong, it's basically the 10th guy on the bench against LeBron James. Usually LeBron James wins. Okay, but hey, you prove LeBron James wrong, guess what? You become the next LeBron James. Okay, so that's what economists do, and that's what the scientific method is. All right. The formal definition of the scientific method is the following. Okay. The dispassionate development and testing of theories of how the world works. And again, I just told you right here what that entails. All right, for economists, it is difficult for us to conduct experiments. All right. Let me copy this out. For social scientists and economists, it is difficult for us to conduct experiments. Why? If you're doing experiments in biology or chemistry, like you want to see if some drug cures cancer. You give it to a bunch of rats. You give cancer to a bunch of rats. You give the drugs to the rats, and then you cut their heads off and cut them apart to study if the stuff works. Well, for us, we deal with people, and if I want to study what happens if people go through bankruptcy, is that going to affect their spending and saving habits? Well, I can't get half of you guys and bankrupt you to see what you guys will do. Okay. Many times, what economists do is develop models. So now let me go and give you what a model is. Okay. We develop models to explain economic concepts and answer economic questions. Model, simplified representation of a real situation that is used to better understand real life situations. Okay, so basically, what we do is we create models, and trust me, we're going to get into a bunch of models here in this whole class. We create a model of the world, a simplification of the world to answer a very specific question. These models involve diagrams and equations, and they're all built on assumptions. We make assumptions to simplify the models, omit because the real world is very complex. And we want to omit a lot of the details to have a cleaner analysis, to focus on the question at hand. Okay. All right. On the next issue, let's bring it up here. In economics, we're going to say stuff like all things equal. All things equal assumption is all other relevant information or factors are remained unchanged. Okay. Assume everything else remains unchanged, and the price of phones go down. What would happen is that people will want to buy more iPhones. Okay. So all other factors remain unchanged. Why? Because we just want to focus what would happen if the price of iPhones go down? What would happen to the amount people want to buy? Okay, we don't want to make this more complicated by changing something else. Okay. We're trying to treat the economy or the economics as close to a laboratory science as possible and only change one variable at a time. All right, I'm going to clear this and introduce to you your first model. All right, your first model is called Production Possibilities Frontier. All right. And let me put this stuff on the board. Oops. Oh, no, oh no, oh no. I just made a boo-boo. Okay, hold on. All right. The Production Possibilities Frontier, or what I call PPF, is a diagram that shows the combination of two goods that are possible for society to produce at full employment. Okay. What we are going to use is we're going to use this PPF to answer several questions. Okay. How much can we produce given resources? What will it cost us to change our mix of production? Does it make sense to import the goods from somewhere else? Well, there's other questions we could answer as well. Okay. And we're going to focus on the following four questions. Okay. What we're going to use is we're going to use the PPF to provide you an understanding of the following ideas. Okay. So let me put this up here. So what I'm going to do is introduce to you um, the PPF. I'm going to introduce to you in two different forms. Okay. And the first form I'm going to introduce to you is a nonlinear form. And I'm going to use that to focus on teaching you about these 4 topics: attainable versus unattainable production and output. Okay, production, which is output, and consumption. Efficient versus inefficient use of resources. Concept of opportunity cost. I'm going to introduce the concept of opportunity cost and the concept of factor specialization. What is factor specialization? Some things, some equipment, some land, some people are better at doing certain things versus other. Tom Brady is a fantastic quarterback. He's very good at playing quarterback. He's horrible at running back and at cornerback, or playing nose tackle or any other defensive position. Okay. So that's the idea of factor specialization. All right. So let me introduce to you the PPF. Okay. The PPF, or the production possibilities frontier, we are going to draw this assuming the following. We're going to assume we have an economy with a fixed amount of resources. And technology. Okay. I use A, the letter A, for technology. Okay. K is for capital. And there's 3 types of capital here. There's physical, which is like machines, computers, etc. Pizza ovens. Okay. There's human capital. This is knowledge, knowledge of how to be a lawyer, knowledge of how to be a medical doctor, stuff like that. And there's financial. This is basically money. Okay. And then there's labor. L is for labor. Okay. That's a resource, people. And land. I don't know what letter to use, so I'll just put land. Okay. So these are the resources of the country or the economy. We'll just keep it simple and stupid and say it's a country. And they have a technology of a certain year. Let's say technology of United States 2021. Okay. And given all of that stuff, we could draw something called a PPF. Okay. Okay. This is drawn in this 2-dimensional world. This is a PPF, or production possibilities frontier. And what we are going to do is show the output of 2 different goods, say pizza, and quantity of guns. Okay, so this simple economy, it could produce 2 different goods, pizza and guns. And obviously, where they meet is the origin is 0, 0 for both. Okay, a PPF, the way we're going to draw it right now, is a quarter circle. It's a nonlinear PPF. Why? Because we're going to show factor specialization with this. All right. It's a quarter circle. This is actually the PPF, this line. Okay. You have some point A, and if it's on the PPF or B inside the PPF, this amount of guns and pizza, say, I don't know, I'll just draw it straight down. That has, I don't know, 50 guns and 50 slices of pizza. And this one here has 75 guns and, I don't know, 80 slices of pizza. These are attainable consumption by this economy, given the technology, the amount of capital it has, and the resources it has: capital, land, and labor. So what I'm going to do is put up the 4 questions, the key questions I want to answer. Okay. Cost for uncertain. Okay. So here, A and B, so A is on the PPF and B is inside the PPF. These are attainable production and corresponding consumption, assuming no trade. So you eat what you kill. These are attainable by this economy. C is out here. Okay, let's choose a different color. For C, this consists of, I don't know, 100 guns and, I don't know, 110 pizzas. This is outside of the PPF. So this is considered unattainable by the economy, given the capital it has, the labor, the land, and the technology it's using. Okay. So what the PPF does is cut the boundary between attainable production and corresponding consumption, and unattainable, which is outside the PPF. Okay. All right. So I did this one. Now let's talk about efficient versus inefficient. All right. So let me get some erasers out. Okay. Uh-oh. All right. Here at point B, the economy is producing 100 guns, 50 guns and 50 slices of pizza. Okay. Okay. So there we could see, can the economy do better than bundle B? Well, yeah, anything in this shaded region is superior to B because, say, C, let's say right there, C, D, or E, all has at least more guns and or more pizza than B. And they are all attainable. So those are all better than B. Okay. Specifically, can we do better than C, D, and E? Yeah. F, G, H. Oh, Jesus. I don't even know what letter I'm doing. H. Those are all better. If we continue with this, we will get to points on the PPF like A, I, and J. Can we do better than I, A, and J? No, we cannot do better than these. We cannot do better than this because everything better than that is unattainable. Okay. All bundles on the PPF is the best we could do with the resources at hand. Anything inside the PPF, well, that is not as an efficient use of resources. Specifically, if you're producing at, say, point B or point C, okay, if you're producing at B or C, for example, some of the capital, some of the land, some of the labor is not being used. We have unemployment. It is an inefficient use of resources. Okay, while being on the PPF is an efficient use of resources. All right, so we answered that one. Now let's talk about the concept of opportunity cost. Let me erase to get a clean picture. Yeah, let's just erase everything. All right. I'm going to draw another PPF. Quantity of pizza, quantity of guns, draw a quarter circle. All right, let's suppose this economy is right here at point A. We're only making guns and we're not making any pizza. So we got a ton of guns, but our people are all hungry. Okay? And we realize, oh, this is no good. As an economy, we realize we got to get some pizza. So we want to go to point B. Okay? So right now, I don't know, we have 100 guns and 0 pizza. And we want to go to point B. Okay? And we want to make, I don't know, 35 pizzas. Okay? And to get there, we have to give up some guns. Specifically, we gave up 20 guns to get 35 slices of pizza. The cost of getting 35 slices of pizza or moving from A to B is 20 guns. That's the cost or the opportunity cost. Okay. The opportunity cost of 35 pizzas is 20 guns. All right. I showed you the concept of opportunity cost. Now what we're going to do is talk about factor specialization. All right. So for in order, I'm going to use this and I'll put up C and D. And here's, let's say 100. And here, I don't know, let's say that's like 90. And this is like 45 or something. Oh, no, nope. 45. Okay. Let's say we're at point A. Again, we're making 100 guns and we're not making any pizza. We realize our people are hungry, so we decide to go to point B. We only had to give up 20 guns and we ended up with 30 pizzas, 35 pizzas. Okay, we didn't give up much here, but we got a lot more out. Okay. The reason for that is because of factor specialization. Right now, if everybody in our country or in our economy is producing guns, that means the pizza ovens are used to make guns, as well as the best chefs in our country that are all being used to make guns. They suck at making guns, and they're very good at making pizza. But we force them to make guns. Okay? And when we tell our economy, when we realize that we need to make some pizza, the first people to move out to start making pizza and move away from making guns are those superstar chefs and the pizza ovens. We didn't give up much gun production, but we got a ton of pizza production. Okay. Okay. Now let's look at C and D. This is again the concept of factor specialization. Here, we got 45 guns and 90 slices of pizza. And we realize we need more pizza. So we want to get the extra plus 10 of pizza. We have to give up 45 guns and we only get 10 slices of pizza. Again, the reason is when we're at point C, only the hardcore gun producers are making guns, and the hardcore gun tools are making guns. The guy, who worked at the Colt and Beretta factory for 50 years using these very specialized gun tools, they're the ones that are making guns. Now we take them out of making guns and we tell them, start rolling pizza dough. Well, they suck at that. So their productivity is going to be super low and they're only going to put out 10 pizzas. And we had to give up 45 guns. Okay. Again, I use this picture to show you how maybe certain people out there, and hopefully this makes sense, certain people and some machines out there are very good at doing one thing versus another. So if we force them to do something else that they're not good at, our extra production is very low and we give up a lot. Okay. All right, we're done with this concept. And now what I'm going to do is I'm going to use, oh, no, you know what? Let's go back. Let me clear this and let's do comparative statics. What is comparative statics? It's a fancy way of saying change an assumption and see what happens. Okay. All right. So what do I mean by that? Okay. I drew this picture, quantity of pizza, quantity of guns. I drew that picture, the quarter circle. This is the PPF, assuming a specific technology amount level, specific technology level, a specific amount of capital, human, physical, financial, specific number of acres of land, and specific number of people. If any of these changes, it's going to change the shape of the PPF. Let's suppose technology increases, okay? So for example, comparative statics, suppose technology increases. How will that affect the PPF? Well, currently it was drawn like this, technology increases. One of you guys will say, yeah, that's going to increase like this. It's going to make us more productive. And that's a perfectly good answer. Another one of you will say, no, it's going to affect pizza production more than gun production. It'll look more like that. Perfectly reasonable answer. The last person will say, no, it's going to affect gun production more than pizza production. So it'll look more like that. Another reasonable answer. If I give you a vague question like this, technology increases, and there are 3 possible correct answers, all 3 are fine, I will give all 3 100%. Okay. Now, if I said something like, let me erase some of this. If I say something like, I don't know, there's a increase in immigration labor, and they're very good at making pizza, and they are good at making pizza. Well, then it's likely the correct answer is something like this, where the impact on pizza production is greater than the impact on gun production. Okay. Okay. All right. We are now done with that. And now what we're going to do is we're going to use straight line PPFs like that to talk about the concept of comparative advantage. Let me clear this. Let's move on. Okay. So let me give you. Comparative advantage and gains of trade. This model is this application of PPF is a little bit more theoretical. And so let's go through this. And there's no one right answer. It's kind of there's actually going to be several right answers. You will see when I talk about trade. Okay. All right. So let's go through this. Theory of comparative advantage. It makes sense to produce the thing you're specialized, especially good at producing, and buy everything else from others. That's kind of the idea that I want to, or this a model is trying to explain to you. If you're very good at doing accounting, might as well be an accountant. And let's say you love it. Better yet, you're good at it and you love doing it, be an accountant, because if you love doing something and you're very good at it, you're probably going to make a lot of money doing it. And then everything else, like you don't know how to fix cars, pay someone to fix your car. You don't know how to make pizza, pay someone to buy some pizza at Domino's. Okay? That's what this idea is saying. Do the thing you're good at and buy everything else from others. Learning objective. Why do people, nations, economic agents choose to be economically interdependent? How can trade make everyone better off? What is absolute advantage? Okay, what is comparative advantage? A couple of definitions I'm going to teach you. How are these concepts similar and how are they different? Okay, so these are the type of questions that we're going to deal with this next application of the production possibilities frontier, or PPF. Okay. Principle of comparative advantage. An economic agent, whether you're a household, person, or country, somebody who makes economic decisions are called economic agents, is better at producing something based on this thing called opportunity cost, on the concept of opportunity cost, than others, then it should produce that good. That's what comparative advantage is. If you're better at something compared to others using this concept of opportunity cost, you do that thing and let the others do other things. And you buy that thing, other things from them. What we're going to see is when companies, households, countries, etc., specialize, meaning they only focus on doing the things they're really good at, and they trade, meaning buy the other things. Okay. They will be generally better off, will have more stuff than if they did not do any trading and did everything themselves. All right, to do this, I'm going to have to clear this picture and introduce you to the model. Let's do this. So the model, okay? So we're going to have two goods. We're going to have the x-axis good and the y-axis good. And we're going to have two agents, economic agents. We'll say country 1 and country 2. And we're going to have linear PPFs. So one's PPF, the equation is the following. Y is equal to minus A over B x plus y1. And 2's PPF is the following. Y is equal to minus C over D x plus y2. So what does that look like? Here, we live in these two worlds. This is country 1. This is country 2. Okay. Country 1, we have the y-axis good, quantity of y-axis good measured on the y-axis, quantity of the x-axis good measured on the x-axis. Same for country 2. Okay. A, B, C, D are numbers. Okay. And they're all greater than 0. So if A, B are numbers that are greater than 0 and put a negative sign, this is an equation of a line. This is also an equation of a line where we have the y-intercept here being y1, and the y-intercept here being y2. Here's y2. And then what I'm going to do for completeness is say there's an x-intercept x1 and an x-intercept x2. And then the slope of this is equal to minus a over b. And the slope of this is equal to minus c over d. All right. All right. So now let's start introducing you to certain concepts. I'm going to do that on the side here. First concept is absolute advantage. An agent has absolute advantage in the production of a specific good, X or Y, if that agent can produce more of that good than other agents. Okay, so how do we find out what absolute advantage is? Let me give you the answer. You just look at the y and x intercept. Okay. If y1 is bigger than y2, like this is 100 and this is 50, then country 1 has absolute advantage in producing y. This good, y-axis good. If x1 is greater than x2, then country 1 has absolute advantage in producing x. And the opposite day is true. If y2 is greater than y1, country 2 has absolute advantage in y, producing y. If x2 is greater than x1, then country 2 has absolute advantage in producing x. Okay. All right, let's move on and talk about comparative advantage. So let me clear this. Comparative. An agent has comparative advantage in the production of a good if it can produce that good at lower opportunity cost than another agent. This means the country with comparative advantage has to give up less of producing the other good. Okay, so so how do we figure this out? We're going to use the slope. Okay. The slope is what we are going to use to figure out comparative advantage. The slope provides the opportunity cost. Okay, so let's talk about this. All right. So suppose the slope is the following. Okay. Remember what the slope tells us. The slope, is equal to rise over run. Okay, it goes to rise over run. Okay. So if I give you something like this, there's quantity of beers, quantity of chicken wings. These are the two goods produced by this country. Okay. And we say the slope is equal to -2. That is the rise over run. That means if I'm here and I have 100 beers and 0 chicken wings, and I want my first chicken wing, I have to go down -2. I have to give up 2 beers to get 1 chicken wing. Okay, I have to give up 2 beers to give up 1 chicken wing. Okay, what the slope tells us is how many y-axis good we have to give up to get 1 x-axis good. Now, if I give up 1 wing, so if I went the other way, 1 wing, how many uh, uh, beers do I get? I get 2 beers. So if I only want to give 1 beer, I have to give up half a wing. It's the inverse of the slope. Okay, so the slope provides, oops, can't even spell, number of y-axis good that has to be given up to get 1 x-axis good, right? Got to give up 2 beers to get 1 chicken wing. So basically the slope gives us, opportunity cost for 1 x-axis good, or 1 chicken wing. The inverse of the slope, you put 1 over the slope, or 1/2. That is the opportunity cost for 1 y-axis good. Okay, and that's it. We use opportunity cost, the slope, I'm sorry, as the opportunity cost. So I'm running out of space here, so let me clear this. Okay. Let me write out what I have in my notes. So here it is. Here's a summary of what I just said. For our model here, where our slope is minus AB and minus CD, for country 1, for each x, we need to give up AB units of y. And for each y, we need to give up the inverse of the slope, or BA units of x. For country 2, we look at the slope, CD. For each x, we need to give up CD units of y, and for each y, we need to give up the inverse of this, which is DC units of x, okay? All right, so then let's suppose we have the following, okay? Let's suppose, let's say country 1, the slope is equal to -2, and country 2 slope is equal to -1. What that means is that for country 1, they have to give up 2 goods, 2 y-axis good to get 1 x-axis good. For country 2, they have to give up 1 y-axis good to get 1 x-axis good. Who has to give up more y-axis goods to get 1 x-axis good? Country 1 does. Country 1 has to give up 2, in our case, beers to get 1 chicken wing. Country 2 has to give up 1 beer to get 1 chicken wing. Okay? So country 1 then has the comparative advantage in producing, country 2 has the comparative advantage in producing the x-axis good. Okay? So let's write that out. Oh, geez. Let's write this out. And this is all the explanations I've already done, so I don't need to do that again. If AB is greater than CD, country 2 has comparative advantage in producing X. Country 1 has comparative advantage in producing Y. Remember, because the inverse of the slope is used as the opportunity cost in producing Y, whoever has the comparative advantage in producing X automatically does not have the comparative advantage in producing Y. Okay, so once you find comparative advantage for one good, it's opposite day for the other good. If BA is less than CD, country 2 has comparative advantage producing Y, then automatically knows country 1 has the comparative advantage in producing X. Okay. All right. So specialization. How does specialization work? Okay. The agent specializes in producing the good it has lower opportunity cost in. So it has comparative advantage in something, that's what it produces. So if AB is greater than CD, country 2 has comparative advantage in producing X. So it's specialized and only produces X. Country 1 has comparative advantage in producing Y. So it specializes and only produces Y. Okay. All right. Now, without trade, each country will only produce and consume within its own PPF. So let's show this. Okay. Let me just clear everything, draw it again. So let's say this is y-axis good, x-axis good, y-axis good, x-axis good. This is country 1, this is country 2. Okay. Without trade, country 1 is not trading with country 2. So if it decides it wants to eat, I don't know, this many of y, let's say 10 y's, and I don't know, 5 x's, then if that's what it wants to eat, that's what it has to produce. Okay, it could only eat what it produces. Country 2, same thing. If it wants to produce, say, point A, 5 of these and 6 of these, then it's all it could eat. However, if countries specialize and only produce what they're really good at, and they trade with the other country, we will see they will produce on the PPF, but they will consume outside of the PPF. They will be able to consume more than the PPF. All right. And trade will occur, and trade will only occur if it's between, if the price of trade is between the slope of the two PPF. Trade only occurs if the price of trade is between the slope of the two curves. Okay. So what I'm going to do is I know there, so what is which exactly the price? I don't know. It's between these two numbers. So if this is like 2 and this is like 1, it's going to be any number between 2 and 1. It could be hundreds of different numbers. Okay. So because it's so theoretical like this, we're going to do one with a numerical example. Okay. All right, let's do this. I'm going to do the farmer rancher one. Okay. Example in our notes. So the rancher example. We have two PPFs here. Okay. We got the farmer and we got the rancher. And they either produce meat or potatoes. Meat or potatoes. Okay. And what we have is the following linear PPF model. And here, y-intercept is 8. And here, this is 24. And here, this is 32. And this is 48. The slope here, rise over run, is down -8 over positive 32, which is equal to negative 1/4. And the slope here is equal to -24. So it's just like down 24 and across 48. Basically, what I'm doing is assuming I start at this point, go down -24, go across positive 48 to get to this point. And this is equal to -1/2. That's a quick way of finding slope. Okay. All right, we see here we have two countries, farmer and rancher. And we could see one thing is the rancher has absolute advantage in producing meat. If it dedicates all its resources to meat, the y-intercept is 24. It can make 24 cows. Farmer could only make 8 cows. Rancher also has absolute advantage in producing potatoes. If it dedicates all its resources to produce potatoes, it can make 48 potatoes. Farmer, if it did the same thing, it could only produce 32 potatoes. So we could see here that the rancher has absolute advantage in producing both meat and potatoes. Okay, let me write that down. Rancher has absolute advantage in producing meat and potatoes. We will see, even in this type of situation, a very large country like the rancher or United States trading with a small country like Vietnam or Korea, okay, the farmer. The US or the rancher will be better off than doing everything themselves. Okay. Rancher is a bigger farm than the farmer. And yet we will see it could be better off with trading with the farmer. All right. Now let's look at opportunity cost. Okay. For the farmer, for one potato, it has to give up 1/4 of a cow. For one meat, it has to give up 4 potatoes, right? Because it's the inverse of this. For the rancher, not the meat, the rancher, for one potato, it has to give up 1/2 a cow, the slope. And for one meat, it must give up the inverse of this, or 2 potatoes. The farmer is very good at making potatoes, or better at making potatoes than the rancher, because it only has to give up 1/4 of a cow, while the rancher has to give up a whole cow. But to produce meat, the rancher only has to give up 2 potatoes, but the farmer has to give up 4 potatoes. Okay. So the comparative advantage here is the following. The farmer has a comparative advantage in producing potatoes, and the rancher has the comparative advantage in producing meats. Okay. Now, if the rancher and the farmer are left to own their own devices, they eat and produce on the PPF. But we will see what happens if they trade. Okay. If they decide to trade, the farmer will only produce potatoes. Okay. So the farmer will only produce potatoes. The farmer will be here. That's farmer's production. And the rancher production is here. So the farmer produces 32 potatoes and the rancher produces 24 cows. Okay. What I'm going to do now is put out the PPF formula to easily do the analysis. Let me put that out right now. Okay. For the farmer, its meat is equal to 1/4. The slope is 1/4. P, potato, plus 8, the y-intercept. And the rancher is meat is equal to 1/2, which is the slope, times P, or potato, plus 24, the y-intercept. All right. So let's go through this hypothesis. The farmer, it sits here and it produces 32 potatoes. It knows it's the end of the year and it needs to trade potatoes for some cows from the rancher. What we have to do is figure out, well, how many potatoes is the farmer going to eat? Let's say the farmer wants to eat this many potatoes, P star of potatoes. Let's say that is 16. If the farmer is going to eat 16 potatoes, it's going to trade 16 potatoes because it produces 32. It wants to eat 16. It's going to have 16 to trade. Before the farmer goes to the rancher's house, the farmer is going to do some analysis. He doesn't want to get suckered by the rancher. So he's going to say, okay, let me think about this. If I eat what I kill and I want to eat 16 potatoes, then how many meats can I produce if I just don't do trade at all? Well, if I put in 16 potatoes into my PPF formula, it's 16 potatoes times 1/4, which is 16 divided by 4 is 4. And it's 8 minus 4, so it's 4. I would be able to eat 4 cows and 16 potatoes. So the lowest amount of meats that I'm going to trade for these 16 potatoes I'm taking to the rancher. Remember, I'm taking 16 potatoes to the rancher, is 4. Why? Because if I trade for less than 4, say 3 cows, then I'm doing worse than if I just did everything myself. So the lowest offer I will take for the rancher is 4 cows for my 16 potatoes. Okay. All right. So now the farmer goes to the rancher and says, look, I got 16 potatoes to offer you. What are you going to give me? And the rancher, he does his analysis. He knows his PPF. He knows, this guy just gave me, he's offering me 16 potatoes. What should I offer him? Well, let's see, what would I do if I'm just left by myself? If I want to eat 16 potatoes, I got to divide by 2. So I got 8. 24 minus 8. What is that? 24 minus 8. That's 24. That's 16. Okay. If I'm left to myself and I really want to eat 16 potatoes, I would have 16 cows to eat. The most I want to trade him, because right now I have 24 cows, is 8 cows. That's the most I'm going to trade for him. If he demands 9, forget it. I don't want any cows. I don't want any potatoes from him because I could just do better off not trading with him and do everything myself. Specifically for the farmer, lowest price for trade is 4 meats or 16 potatoes. For the rancher, the highest he's going to offer for trade is 8 meats for 16 potatoes. Okay. So if I make a ratio of meat to potatoes, it would be 4 meats to 16 potatoes, or 1/4. Meat to potato ratio here for the highest price of trade is 8/16, or 1/2. What is that? That's the slope. Okay. The lowest price for trade is the farmer's slope, or for 16 potatoes, 4 meats, and the highest price for trade for 16 potatoes is 8 meats. Trade will only occur between the two slopes. It has to be between. We know we have 16 potatoes for trade. So we need to, the trade will only occur if between 4 to 8 cows or meats are offered. Okay. All right. So how many is offered? Well, that depends on the negotiations of the farmer versus the rancher. Whoever is better at negotiating basically wins, right? So let's look at this. Oh, I can't erase this. Let me just erase what I can erase. All right. So we know that trade has to occur. We know trade will occur if 4 to 8 meats are agreed upon. Let's just pick a random number. Let's say 5. Let's say they negotiate for trade and it's 5 meat for 16 potatoes. Okay. So let's see if the farmer and the rancher are better off. Let me clear this because everything got screwed up. Okay. So we have this one, and we have this one, and this is the farmer, and this is the rancher. And for the farmer, let me just redraw everything so we don't get confused. We have meats, rancher, we have meats, and potatoes, 2 ppfs. And right here, this was 24 and 48, 8 and 32. Let me put up the equation. For the farmer, the ppf equation is meat is equal to -1/4 potato plus 8. And the rancher is meat is equal to -1/2 potato plus 24. And we know that a farmer, this is production, and it decides to eat 16 potatoes. And if it's left to its own devices, he would have 4 meats. Okay. And this is what he traded. For the rancher, this is production, 24 cows or meats. He was given 16 potatoes, and left to his own devices, if he ate and what he killed or just ate what he can produce, he would have 16 cows and 16 potatoes. Can he do better? And can the farmer do better? We said trade will only occur if 4 to 8 meats are traded for 16 potatoes. We picked, suppose, 5 meat are given. Well, let's look at the farmer. Is he better off? Would he take this trade? Well, he's eating 16 potatoes, and now he has 5 meats. Rather than being on his PPF, he's eating outside of his PPF. He's better off. Of course, he's going to take it. What about the rancher? He's given 16 potatoes for the 5 meats. And how many meats does he have remaining? So he had to give up 5 meats. He's producing 24. Okay, so if you give up 5 meats and you're producing 24, you have 19 left. Again, the rancher is producing on his PPF and he's eating outside of his PPF. They are both made better off. So they will both do this trade. Okay? This shows you that if countries or people specialize and they trade for things that they're not really good at doing, they are going to be made better off. And if both countries in this case are made better off. All right. Now let's do comparative statics. Okay. Let me clear this. Again, what is comparative statics? Change an assumption and see what occurs. Okay. Okay. All kinds of things could change. Remember, when I draw this PPF, okay, I drew it assuming a certain amount of workers, technology, capital, etc., etc. If one country gets more labor, it's going to change their PPF. Suppose the farmer gets more laborers. Well, it's going to shift out the PPF, right? Okay. Let's do this. So right now we have the farmer's PPF. It looks like this. Okay. And you have meats and potatoes. And we have 8 and 32. Okay. If it got more laborers, suppose labor increase, it will change this PPF. And depending how it changes it, the farmer may specialize in producing meats. What if it changes it parallel like this? Then it will continue to produce meats because its slope remains the same. But what happens if it gets steeper, or what happens if it gets flatter? It could switch. It's because it switches the slope, it can switch the opportunity cost such that the farmer now is better or has lower opportunity costs in producing meat compared to the rancher. Increase, decrease in technology, same thing. What you need to do is that when labor changes, when technology changes, when capital changes, you need to recalculate the PPF, recalculate the slope, and then go through the analysis again and compare the slopes to see if comparative advantage changed. Okay. All right. We are done with this part. Let's move on. Clear this. The next thing we are going to learn about is called the circular flow diagram. Okay. Okay, what is the circular flow diagram? The whole point of the circular flow diagram, let me copy this over, is to show how the dollars move through the economy. It's a very simple model, and it tries to show how money moves through the economy. So what are the assumptions? Let me give you the assumptions. Okay. We are going to assume the following. We have two decision makers. Two decision makers. One is the households, and the other is firms. Households, they have all the resources. Okay, they own all the physical capital, they have all the knowledge. Obviously, they have their bodies, so they are the ones who provide the labor. They have all the resources of production. Okay, firms, they want resources because they have ideas to make outputs or finished goods. Okay. Households, they have all the resources, but want finished goods. Okay. Households have all the resources, but they don't care. They want Ferraris and white t-shirts. Firms, they have these ideas of how to make Ferraris and white t-shirts, but they don't have the resources to make them. Because of this, we're going to have the following situation. Okay? We're going to have the decision makers in these boxes. And this is HH for households, and this is firms. Households have a bunch of resources. Firms, they want resources. Because of that, they're going to meet at a swap meet. And we call this the input or the resource market. Okay? The households, they bring the resources here. Okay? Rent or sell. We'll just say rent for now. Resources. Okay? They offer up the resources. The firms, they take them. Okay? Rent, resources. But they can't get it for free. Everything costs money. They have to give them the money. They take them to the input market. They take money. They trade the money for resources. And the households get the money. But remember, the households, they're not happy with money. Okay? You got to remember one thing. Money doesn't make you happy. It's all the cool things money could buy that makes you happy. Okay? All right. So knowing that, we know that there's going to be another swap meet. It's called the output market. Okay. And the firms, they're going to take the outputs and they're going to sell the outputs. And the households, they're going to buy the outputs. And again, households can't get that for free. They got to take money there and they got to pay for it. And the money goes to the firms. And the cycle repeats. Money flows through the economy, between the two decision makers, firms and households, through these two markets as resources are being exchanged and output is being exchanged for money. Okay, this is the circular flow diagram. In this circular flow diagram, it's a very simple diagram. We don't have the super complexity of the real world. What don't we have? We don't have trade with other countries. We don't have fancy banks. And we don't have, say, households working for other households. Households only work for firms. So simple things like gardeners that come to your house and you pay them money, that can't happen in this very simple world. Babysitting cannot happen in this very simple world. But who cares? Those complexities are not needed. All we want to do is create a very simple model that shows how dollars flow through the economy. And we accomplish that. All right, let's clear this and move to another topic. Now what we're going to do is talk about normative versus positive analyses and statements. Yeah. Most of economics, oh Jesus, hate them. I hate sometimes Canvas and Zoom. Okay. Most of economists out there, we deal with positive economics, positive statements. Okay. We try to describe the world as it is. We are descriptive. Whatever we say can be confirmed or refuted by examining data. For example, if I said, hey, if you go to Ralph's, cookies cost $500 each. You could go to Ralph's, look for these $500 cookies and say, no, you're BSing. I found cookies for 50 cents each. Or you could say, yes, I found a picture. I took a picture. Here's a cookie that costs $500 each. We could confirm or refute by looking at the evidence. We try to be objective, scientific, involving questions of facts. We try to deal with the question of what is, was, or will be. Some economists, and usually we don't like dealing with this, but some do, and they get paid a lot of money to do this, and mostly lawyers do this, is they deal with normative statements. They try to be prescriptive, how the world should be. It's subjective, it involves opinions. I would say something like, cookie prices at Ralph's is too high. Well, what does that mean, too high? Compared to what? Too high, too small, too low. You know, LeBron James is the best basketball player in the world. I think it's Michael Jordan. And we would argue. Okay? And no one will be right, no one will be wrong. It's hard to refute normative analysis. It's very easy to refute positive analysis. It's very easy to support positive analysis. It's hard to support normative analysis. Okay? Positive economics is about being descriptive. Normative is about prescriptive or opinions. Okay? All right. We are done with this chapter and done with this lecture. Goodbye.